Okay, hi guys. We're gonna do question 4. Question 4 of the May 2003 M1 paper. The question has a diagram that looks like this on the paper, and that's angle alpha, and there's a block on the plane, and the question says that the parcel has a mass of 5 kilograms, and it's on a rough plane. It's on a rough plane, and the angle they tell us is given by tan alpha is equal to 3/4, and they say the parcel is held in equilibrium by the action of a horizontal force like that, and this is shown also in the diagram, and that's 20 newtons. So in other words, it's held by equilibrium. If it wasn't for that force, it would fall forward. Now the parcel is on the point of sliding down the plane. So if this is about to slide, it means that the friction is going upwards, because a rough plane, it means that it's got friction, and the force of friction is given by the mu, which is the coefficient of friction, times the normal reaction to the plane. Mu times the reaction to the reaction of the plane against this. Now, it says to find mu. So to find mu, so we need to find an equation of motion, which we can use to find mu. What's important about this problem is to make a big diagram to make sure that we know what's happening. So, if this is our plane, and this is our block on the plane, and this is our force, that's a force of 20 newtons. Gravity acts at the center of mass of this, and it goes down like that. That's our weight. And we, as usual with these problems, we need to resolve in the directions parallel to the slope, which is this direction, and perpendicular to the slope, which is that direction. So with that diagram now, we can start to think about things, and we also need to include the angle so we know what's going on here with the angle, right? So the rest of the slope looks like that, and if this is an angle alpha, then you can hopefully see that the angle that this force makes with the parallel to the slope, it's also, this angle here is also alpha, right? And what else? Well, let us think a little bit about what's going on here. The reaction force of the plane on the object is going to be this force here. That's our reaction, and that's going to come from all the way down here. It's going to go there, and that reaction force is going to be given by the weight, right? The weight, this angle here, you should be able to see that it's also alpha from a lot of questions like this that we've done, this will also be alpha. And if this is the weight, then the reaction will be made up of several things, but one of the things that it will be made up of is this component down here of the weight. So if this is the weight, then this component down here, let's make a triangle with the weight. We need to make sure that the weight is the hypotenuse. So if this is a triangle with the weight, there's a component of the weight that goes down the slope, which is this one here, and it will be W sine alpha. And there's a component of the weight that is perpendicular to the slope, which will be cos alpha, because this is alpha. Sine deals with opposites and cos deals with adjacents. Now, the reaction which we would need to calculate, because the reaction is times mu will be equal to a force of friction. And we know that a force of friction is balancing exactly with what's making it want to go down the slope. So first let's resolve perpendicular to the slope. Let's say, okay, resolving perpendicular to slope. We have the reaction there will be equal to what's the component of the weight going into the slope, which is this W cos alpha, but it will be something more, because this 20 is also pushing down into the slope. So there's a component of this guy, that guy there, that's gonna be going in the direction of the direction into the slope, and whatever much of this guy that's going into the slope, that's also something that the reaction is gonna have to work against and therefore provide. So it's gonna be made up of an addition of both the weight that's pushing it into the slope, and also the reaction to this 20. So if this is the force of 20 coming in this direction, then let's split up this as a hypotenuse. If this is a hypotenuse, let's split it up in a direction perpendicular to the slope. So if this is the slope, then perpendicular to the slope would be here. Perpendicular to the slope would be there. And down the slope would be this purple one here. So you've got this down the slope parallel. So if we split this 20 and force up the slope, it would be up the slope in this direction. And perpendicular to the slope, it would be this one. And this triangle makes sense because this is a right angle and the hypotenuse is the real force. So we've done well here, and I think it's quite easy to see from the diagram, even though it's a bit getting involved. I hope that you can see that. And so really we need to find out this angle here, right? And this angle, hopefully you can see that if this is the horizontal and this is parallel, because it's coming in at a horizontal angle, then, and this is the same line of the slope coming up, and this is parallel, then you can see that this is also alpha. So if this line here, if this angle there is also alpha, then this guy here will be 20 opposite of alpha, so 20 sine of alpha. And this up the slope will be 20 cos of alpha. So now that we know that the 20 sine of alpha is pushing down onto the perpendicular of the slope, as well as the W cos alpha of the gravity, and they're both making up the reaction which needs to fight with both of those, then hopefully you can see that this here will be 20 sine of alpha, and that will be our reaction. Reaction will be given by those two things. Now, the equation resolving parallel to slope looks like this. Let me see. The component of the weight that wants it to go down the slope is going to be this, right? W sine alpha. So W sine alpha. What else is making it go down the slope, but nothing else, because this force here is making it go up, and the friction is also making it go up, because we're told it's at the point of equilibrium before it slides down. So in the question they give us the clue to say, okay, friction is definitely going to be going up because it wants to slide down, and therefore this whole force going down the slope needs to fight with the other two going up. One of them will be the force due to the reaction, and it's going to be the parallel one, so 20 cos alpha. And the other one is going to be the one of the weight. So, sorry, the one of the weight that went down, and the friction. Sorry, and the friction is going to be what color are we giving the friction? Let's give it a yellow color. And the friction is going to act always along the slope, so we don't need to resolve the friction at all. We can just write down the force for the friction straight away, and that friction there is going to be equal to, as we said before, the force of friction is mu r. So that's going to add to the 20 newtons pushing it up along the cos of alpha, and these two together are going to have to equal to W sine alpha, because it's on the point of moving. So these are our two equations we have right now. We have okay, and here R we had it in orange, so let me put this in orange so that it's clear it's the same R. Yeah, that's the same R as this one here. And so now with these two equations we can find mu. So let's do some algebra and find mu. R is this, so we can put R in there and then solve for this. So let me check how we're doing for time. 11. So we have about 3 or 4 minutes, so let's try to do this quickly. W sine alpha is equal to 20 cos alpha plus mu times R, and R is all of that, so we have W cos alpha plus 20 sine alpha. And so now we gotta fiddle with all of this around, and then we're left with mu is equal to W sine alpha. We pass this one to the other side and we get minus 20 cos alpha, and we divide this by all of that. So we've got W cos alpha plus 20 sine alpha. If you compute all of this, and then alpha, we were told that the tan alpha is equal to 3/4, and that's kind of convenient because triangles that are 3/4, if this is the angle alpha, then OA is opposite over adjacent, which is the 4, and the triangle that's got a right angle is 3, 4 always has a hypotenuse of 5. This is called the Pythagorean triangle. 3 squared plus 4 squared is 9 squared plus 16, and that's 25. 25 square rooted is 5. So then we can get our sines and our coses from this triangle here, and therefore our mu is going to equal the weight, which is mg, which is 5g, times sine of alpha, and sine is opposite over hypotenuse, so that's 3 over 5, so the 5 disappears and we're left with 3g, minus 20 times cos alpha is adjacent over hypotenuse, so that's 4 over 5, so that's 20 times 4 over 5, yeah, 4 over 5, yeah, and that's cos alpha again, so that's 4 over 5 times W, and that's 5g times 4 over 5 plus 20 times sine, which is opposite over hypotenuse, which is 3 over 5. So that should be equal to 3g minus 20 divided by 5 is 4, 4 times 4 is 16, over, this cancels with that 5, then you get 4g plus 20 divided by 5 is 4, 4 times 3 is 12. So if you compute this on your calculator, you should get a number for mu, and they should be smaller than 1 always, and still got enough time, so hopefully I can do this for you and see what we get. Three times 9.8 minus 16, 13.4 divided by 4 times 9.8 plus 12. 51.12, 51.2. So 13.4 divided by 51.2 0.262.